These are the worked solutions to the centripetal force practice questions, focusing on applications, so Ferris wheels, banked corners, and so on. Let's have a look at question 1. So this is a really typical exam question. We've got this vertical circle, a Ferris wheel fairground ride. We're given the radius, and it says it's constant speed. It normally would be, and we're told it's 1 revolution every 20 seconds. So it's quite structured, so it asks us to find the speed, so that should be straightforward. We know V equals S over T, so the S is the displacement, that's 1 circumference, 2 pi r divided by time, so 2 times pi multiplied by 15 divided by 20 will give us 4.7. So that's quite straightforward. Okay, a bit more tricky is part B. It says calculate the reaction force on a 70 kilogram person at the top and at the bottom. Right, so this is where we need to think very carefully about what's happening. So we know that the weight, if we show this by the blue arrow, that always acts downwards. We can calculate weight mg, that's straightforward. The reaction force, that's going to vary. It's going to be smaller at the top and larger at the bottom. So let's talk about what's going on. Remember, there are only 2 forces. There's the weight and there's the varying reaction force. That's it. The centripetal force is the combination of these 2. So if we look at the top, we can see that the weight is larger than the reaction force. So W minus R will be equal to mv squared over R, the centripetal force. And at the bottom, the weight hasn't changed direction, but the reaction force needs to be larger. That's still going to act towards the center. So now the reaction force will balance the weight and also provide the centripetal force. So first thing we need to do is to calculate what these 2 quantities are. The weight, mg, and mv squared over r. So using your value from part A, we can find the centripetal force. And basically we need to say, well, do we add these together or subtract them? But we need to understand why. So let's think about at the top. So at the top, we said that the reaction force take away the weight, beg your pardon, the weight take away the reaction force will be equal to mv squared over r. So if we rearrange that to make reaction force the subject, that'll be W minus mv squared over r. So 687 take away 103 is 584. We can find RT. However, at the bottom, we said the reaction force at the bottom, RB, has got 2 jobs to do. It's got to balance the weight, mg, and also provide a resultant force known as the centripetal force towards the center. So at the bottom, it will be W plus mv squared over r. So we looked in the video lesson about an object on a piece of string, and we said that this is kind of similar and kind of different. At the bottom it's the same, but at the top it's subtly different because there's no tension acting toward the center. So usually it's a case of calculate mg and calculate centripetal force and then either add them or subtract them. But we need to be confident about why we do that. Question 2 is another really typical question. So we have a bridge, a humpback bridge. We're told the mass and we're told the radius of the bridge. What is the largest speed the car can travel before the wheels lose contact with the road? So let's just imagine stationary. So stationary, the weight is acting downwards, the reaction force is acting upwards. That will be the same size as mg, and we have 0 resultant force. And we don't need a resultant force if the car is stationary because we don't need to move in a circle. But as the car speeds up, the weight obviously doesn't change, but the reaction force starts to reduce because something needs to provide a centripetal force. So the centripetal force is W minus the reaction force until we get so fast that at some point the reaction force will reduce to 0. And this is the fastest we can travel without the wheels losing contact. So the point at where the wheels lose contact with the road, the reaction force is reduced to 0, which means all the centripetal force is provided by the weight. So that makes everything a lot more simple once we understand that principle. If the centripetal force is equal to mg, then mg is equal to mv squared over r. So in actual fact, we could cancel m. We don't even need the 1,200. We could just ignore that. We could answer this question only with the radius. But if you want to include it, you can do. You can calculate the weight, and then you're going to have to divide by the mass. So the answer is independent of the mass. So it comes out as, if we rearrange this, then v is equal to root gr. So it's just the value of g multiplied by the radius, and we get 14 meters per second. So what looks like quite a complex question, mathematically is quite straightforward. but that's a very common theme with centripetal force. The maths is not the difficult bit. The difficult bit is understanding what's going on with the forces and how they combine together to make the centripetal force. Question 3, another very typical question that you might see in the exam. So we've got a roller coaster. We've got our vehicle here, which is going to go all the way down, and then it'll be at this point here, upside down. So it says find the minimum speed that the passenger remains in contact. Okay, so at the point of leaving their seat, and you might have experienced this on a roller coaster ride, where you feel like you're coming away from the seat. Obviously, if this was stationary, then without the harness, you'll just fall vertically downwards. So the harness keeps you in the seat, but you're effectively trying to fall because your weight is pulling you down. So at this point, where you're about to lose contact with your seat, the reaction force is 0. Therefore, once again, rather like the previous question, the centripetal force is provided by the weight mg. So it's actually very similar to the previous one. The mass of the person we don't need. And I think that might have confused students if this was an exam question. They might think, well, how do I find the mass? How do I find the weight? You don't need the weight because the mass is going to cancel. So actually, it's once again, it's very similar to the previous question. We just need the radius and obviously g. But do be careful, so this would have caught out a lot of students. The diameter is 15. So the radius is obviously 15 divided by 2. So that's a really important point. Just check you have the radius before you calculate your answer. Question 4, again, another really typical question. So we're told a mass, we've got an object moving in a horizontal circle. It's attached to a wire. So it's kind of moving in this, we often call this a conical pendulum. So because we're given the mass, we're given the radius, and we're given the speed, then we can calculate mv squared over r. So just watch out for the centimeters. So that's obviously divided by 100, and we can work out the centripetal force, 3.85. And then it says find the angle between the wire and the vertical. So this is where we need to think through what's actually happening. Why is this object moving in a circle? Well, something is providing the centripetal force. We've already calculated that. The thing that's providing it is the horizontal component of tension. So this is the tension here. The horizontal component of that we've already calculated is 3.85. The vertical component must be balancing the weight mg. So we can calculate m times g is 1.96. That must be true, otherwise it would not be in a horizontal circle. So that little detail there, horizontal circle, means the forces are balanced vertically. The weight mg downwards is balanced by the vertical component of force acting upwards. So once we have these two, so we've got 3.85 is this value, 1.96 is this value, it becomes a straightforward SOHCAHTOA question. So we've got tan, and make sure you find the correct value. So if you find this one down here from the angle from the horizontal, then you'd certainly lose a mark. It needs to be this value here, the angle between the tension, the wire, and the vertical. So it's going to be tan to the -1 of 3.85 over 1.96. Final question. So we've got a banked corner. So you may or may not get a diagram for this in the exam. If we're told that the angle of elevation, the banking is theta, then that's going to be the same as these angles here, and we can work this through just with geometry. If this is 90, this is 90 minus theta, so that will be theta, and this is theta up here. Okay, so we're told the mass, we're told the radius, we're told the angle. What is the value of r? Now be careful here, because very often we're looking at horizontal surfaces. Very often students make the mistake of thinking that the reaction force is equal to the weight, and very often that would be the case, but here that is not the case. That would not work at all. So this is very similar to the previous question where we had tension in a string, but now it's reaction force perpendicular to the surface, and we need to consider the vertical and horizontal components. So the vertical component of the reaction force, that's the force which balances the weight. So we can calculate the weight, mg, and it will be r cos theta, if we think about this triangle here. R cos theta is the vertical component. So r cos theta equals mg. We can rearrange to make r the subject, mg divided by cos 20, which will give us a value bigger than the weight. And that should make sense, because the r is the hypotenuse of the triangle. And then it says, what is the centripetal force? Okay, now that we've found the value of r, the reaction force, well, as we said previously in the video lesson, Then it's the horizontal component of the reaction force which provides the centripetal force. So we're going to use this value here multiplied by sine 20, and we get our answer here, 2856. So as ever, always show you're working out. If you'd made a mistake up here for some reason in part A, then if you show all you're working out, you should still get full marks for a wrong answer. And once again, we're trying to find the speed. When it says without friction, that means without turning the steering wheel. So there's no friction, there's no centripetal force coming from the steering wheel and turning the tires. We're just assuming that all the centripetal force is provided by the horizontal component of the reaction force. Okay, so then we've got mv squared over r. We've calculated the value of centripetal force, so we can rearrange to make v the subject. We know F, we know the radius, and we know the mass. So we just stick all the numbers in and we can find our answer of 13.4.